didn't yet edit a title to this. Have to do my homework report. Let's do this. Join me. Oh, wrong one. It's awkward. Oh, alright, I gotta mute. Oh, I gotta make sure I mute my. Alright, it sounds good. Don't want to echo. Echo. No echo. Alright, so today we are doing my lab report. Let's do the lab report first. Let's write this in Times New Roman. Oh. Yep. And then can you see that? There you go. Make it smaller. I'll make this bigger. Okay, then make this size 20. I don't know which one it is. I already did this one. I did this one. I think I have to write the paper. Ah, yes, it's the liquid limit test. That one. I think. What the hell is it? Oh, there we go. I was scared for a second. Can you see that? Let me make it bigger. See it now? Yeah, focus. Home focus. Anyway, I gotta put a bunch of these numbers in, do this homework, and then I gotta write a report for that. Wow, that's huge. That's what she said. Report. Oh, we should get some music in here. Yeah, yeah, get some music in here. Let's get some music in here. Let's see. Pull up the stream. I got Lo-Fi Girl in the background. I think Lo-Fi Girl can be played in the background. That'd be kind of. She not streaming? Oh, she is. Okay. Oh, there's an ad playing. Don't want the ad playing. Bum, 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 bum. All right. Yeah, that's right. Lo-Fi Girl. Okay. I think that's good. I think everything's good. All right. So this one, is that big enough? Is that middle of the table or page? I mean, I think. Oh. That's like middle, maybe a little higher. All right, this lab report is called the liquid. It's gonna be irritating. It's called the liquid limit test. Liquid limit test lab report, probably. Lab report. I love these earth science reports. These reports are so much fun to make, obviously. Okay, and then what goes? My name. No, soil mechanics. Oh no, I could put my name. Long to soil mechanics, mechanics. I'll spell that right. I didn't spell that right. I'll spell that right. I sound British. No. So 0, 9, 28, 2000. Emporia State University. That's my university. Don't try to dedox me or anything. Alright. Let's do this. I'll put this on my Snapchat because I feel like people would like it to be on my Snapchat. Let's see. Oh, cool. Ludwig is streaming at the same time I'm streaming. God, it's like I think he knew that I was streaming, guys. That's so annoying. What should I type with this? Cool. Join me in writing my report. The goal is I write a report. I should have done this at like 3 o'clock, but it's whatever. But the goal is to write the report before midnight, and then I can sleep. I usually wake up at like 6 o'clock or so. So, you know, hopefully it'll be good. Alright, you can't see that. Alright. So, when writing a science paper, actually, I'm going to edit my title. Let's teach everyone how to write a science paper, a science report. So how you write a science report, you might be asking. Well, you need to be impartial. Not impartial, but you can't talk in like the first, forget everything you learn in like English courses when you have to write papers for English courses and stuff like that. When you're writing a science paper, you have to be impartial. You have to be talking from a very monotone third person, which is kind of hard to do. That's why you always have to check your work. And always, like, thankfully my professor gave me my papers back so I can fix myself. So now the problem, you have to state the problem. There's a certain thing for it. Problem. And the problem for this lab experiment is liquid limit tests. So basically what we did was we gather a bunch of soil, we wet it, and basically mimic a earthquake or so. And we will put the wet soil in like a small, very circular with a can with a very round bottom, and then it would be like 1 nanometer or so, not 1 nanometer, maybe like 8 nanometers in height, hopefully. And then we make a cross section in the middle of the entire soil, and then it's on a crank, and we're mimicking a what's it called? We're mimicking a like earthquake simulation or some shit like that. And the purpose is to, you know, study the. Well, I don't know what the purpose is. So here's the purpose. Well, I have a lab book. All right, introduction. Here's the introduction. When a cohesive soil is mixed with an excessive amount of water, it will be somewhat liquid state and flow like liquid. Okay, this is shown in Figure 6.1, which the soil mixture has a volume of V at a moisture constant of W. However, when the viscous liquid is dried gradually with the loss of moisture, it will pass into a plastic state. Okay, we don't want that. With a reduction of moisture, the soil will pass into a semi-solid and then turn to a solid state. moisture content and percent at which the cohesives will pass from a liquid state to a plastic state is called the liquid limit of the soil. Similarly, the moisture content in percent at which the soil changes from plastic to semi-solid state, from a semi-solid to a solid state, are referred to as the plastic limit. Okay, that makes sense. And the shrinkage limit, SL, respectively, these limits are referred to as Adalbert limits, named after some asshole probably. It is important to point out the volumes of soil water mixture as shrinkage limit. With further reduction of moisture, the volume does not change. In this chapter, the preceded determined the liquid limit by the Cassegrade precision cut method will be discussed. Okay. Procedure. Alright, this time problem is to determine the liquid limit of a soil. Determine the liquid, and it doesn't have to be limit of a soil, since we have very specific soil, which is the soil that we gather for our lab, of the soil CWF22, which stands for Campus Woods Fall 2022. Determine the liquid limit of the soil. Okay, what does the liquid do? Moisture content percent which the coastal soil will pass from a liquid state. Liquid limit. The liquid. I think I understand it. The liquid limit shows the state a soil. How about measured? I think measure probably measures the state of a soil. Shows the state of a soil from a from a liquid state to a plastic state. Plastic state. Okay. From state to a plastic state. Okay. Procedure. I think we can move on. That's what I'm going to put on for right now. Equipment needed. So, procedure needed for the laboratory so we need a moisture cans. We need moisture cans to put soil in. Did I measure the heck? Oh, okay. Laboratory, our cans, oven, our cans, bowl, some sort of spatula. Balance up to a balance 0.01 grams. Plastic squeeze bottle. Water bottle, how about that? And what's the thing called? Is it called? What is that called? And Casadra's Casagranda Grande Percussion Cup. This experiment will be using the Cassandra. That's a mouthful. Andre percussion cup method to find the data. Okay, this one's a pretty easy lab, but you know how it is with these labs, man. You gotta write like a crap load of them. Okay, this experiment I'm tired. This experiment will be using the Cascade Percussion Cup method to find the data. Okay. First step. Alright, determine the mass. I said ass. Jeez. Determine the mass of the cans for this lab. I'm not in double space for this lab. 3 cans. That's fine. 3 cans were used. On average, let's see. Yeah, they're around like 20 grams per can. Did we do anything different? I don't know if we did anything different. Because we tend to do things differently. $256 grams used sleeve. The experiment, the lab book experiment, the lab book. So instead of using the lab book, has to use the number 40. I'll let that just make sense. Transfer the soil into a sleeve through a sleeve. How about that? Because it's not going in a sleeve, it's going through a sleeve. Transfer the soil through a sleeve, so only fine grains. So only fine, I guess. So only fine grains, not grains, but only. So only fine material will pass through. The lab book asked. So I think we switch up the thing. We switch up the thing. It was like instead of using the lab book asked us to use a number 40 sleeve, which I think this will be better. 40 sleeve, but for this Pacific, I can never spell Pacific. See, but for this Pacific lab, the number 35 was used. Before the soil was transferred into a pan. The previous experiment so for the last experiment we measured, I'm trying to see how I can word this out. The experiment will be using the Casa Grande percussion cup method to find the data, determine the mass of the cans. The first step is to determine I'm dying. Cans for this lab, 3. For this lab, 3 cans were used. Transfer the soil through a sleeve so only fine material will pass through. The lab book asked us to use the number 40 sleeve, but for this specific lab, the number 35 sleeve was used. The soil was transferred into a pan. Let's see. Oh, the soil was transferred into a pan from the previous experiment. From the previous pan's mass is 502.88 grams, I think. Let me check my Excel. Yeah, 502.88 grams. In case alright, actually make sure to measure the mass of or any or that will hold the fine soil. Previous lab, to measure the mass of the pan. Pan's mass is 500 with the added soil. A minimum, a minimum of, oh crap, why does it do that? A minimum of 250 grams are required for the lab. A minimum of 50 grams, a minimum of air dried soil. Oh, I wrote that backwards. A minimum of 250 grams of air dried soil is required for the lab. For this lab, I think we measure out 200. How much did we measure out? Gosh, I don't know. Where's the number? Did I not write it down? Please tell me I wrote it down. I think. Oh yeah, mass of soil. Yeah, we went 256.88. Okay. 256.88 grams were measured out. Yes, air dry soil is required for the lab. Were measured out. Okay. That's very close. That's very 6 grams above. Okay. Equipment needed for the laboratory are cans, bowl, spatula, balance, measure 2.2 100th of a gram. Plastic squeeze water ball, I don't know how to say that. Cascaranda percussion cup. I'm surprised my stream isn't down yet, but luckily low 5 girl comes in handy. Transfer the soil through a sleeve so only fine material, only fine soil. Let's say soil. Transfer the soil through a sleeve so only finest soil will pass through. The lab book asked to use the number 40 sleeve, but for this specific lab, the number 35 sleeve was used. The fine soil was transferred into a pan. Make sure to measure the mass of the pan or bowl that will hold the fine soil. Okay. From the previous lab, the pan's mass. The pan's mass is 502.88 grams. A minimum of 250 grams of air dry soils were required for the lab. Grams were measured out of air dry. Should I even spell the entire word grams? I'm gonna spell the entire word grams. Not only does that add more to my page, but it also, you know, I feel like it helps. I feel like it helps measuring out the entire word. You know what I mean? Drink some water. Ignore the audio for this. It's gonna be slurp session. I'll just censor my mic. That's some good freaking water there. Y'all like water? I bet y'all like water. A minimum of 250 grams of air dry soil is required for the lab. 256 grams were measured out. Okay. So the next step that we did. Okay. Now this is it. This is the fun part. Add water to the to the soil. Add water to the soil. Squeeze. How about squeeze? Squeeze water into the soil. I don't know how to spell squeeze apparently. Squeeze water into the soil, creating a paste. I think like a paste. A paste-like material. Paste-like material. Paste-like material. Squeeze water into the soil. Too much water will form a uniform paste. Squeeze water into soil. Too much water will make the water too wet. Yeah, to make the soil too loose, too liquid-like. How about that? And less water will make the soil dry. What? That doesn't make any sense at all. Well, I mean, it makes sense, and less water will make the soil dry. Yeah, I'm just making that up. Okay. For this lab, I don't want to say that. Okay, let's see. What is a evaporating dish. This slab. Okay, the lab book. Asks for an evaporating disc. Evaporating. I don't know what that is. The lab book asks for an evaporating dish bowl. But this lab, a regular glass bowl was used. Okay. All right. Once the soil has met a what's it called? Has met a has formed a uniform paste spread the paste is that even I don't know what that was. Okay. Spread the soil onto the is that what it's called? Onto the percussion cup? Let me look this up. What does it go to this? Okay, whatever. Spread the soil onto the percussion cup. I'm gonna call it the percussion cup. Percussion cup. Percussion cup. Let's see. Oh, that was bad. To evaporating dish. Onto the percussion cup. Smooth the paste. Smooth the soil with until a depth of 8 nanometers is met. Then groove a center line through the soil, through the wet soil. Okay. Then groove a center line through the wet soil. I can't think right now. Then groove a center line through the wet soil. Make sure the creating two halves of the soil. Oh wait, let's just say halving the soil. Make sure neither half is touching. turn the crank. Of the liquid limit device. I say smoothen the soil until a depth of 8 nanometers is met. Yeah. Then groove the center line through the wet soil, halving the soil. Make sure near half of soil is touching. Then rotate. I think it's rotate. Okay, how about rotate the crank on the liquid. Rotate the crank on the liquid limit device. Okay. Let's see. Right, rotate the crank on the limit device. The cup will move. You know what? That doesn't make sense. Rotate the crank. Crank the handle. The cup will move up and down. Up and down. Every hit. No, you cannot copy my homework, Ben. What are you? Stupid. Move up and down. When the cup hits the cup will hit. Will hit the base of the device. This will, what is it called? This will be called a blow. This will be counted as blows. As we count it as blow ends. Collect moisture sample from soil in the cup. Okay. Oh man. Make sure nanometer is met. Then groove a center line through the wet soil, halving the soil. Make sure near half the soil is touching. Crank the handle on the liquid limit device. The cup will move up and down. The cup will hit the base of the device. This will be counted as blows in. Blend in. Then in. No, it's an actual science paper. Yeah, it's an actual science paper, man. I'm doing my homework and I'm letting people copy my stuff. I'm joking, nobody's gonna copy this stuff. This will move up and down. The cup will hit the base of the device. This will be counted as blows in. Okay. There is. Oh, not there is. I can't think right now. Let's see. Okay. Okay. However many blows, however many blows, stop, stop, stop the crank when, yeah, you haven't gone to the fun part. I'm going to do Excel stuff later. For however many blows, stop the crank when the two halves are touching. The lab asks to have blows between three sets of ranges. Between how many ranges? I bet you can get down if you know what I mean. Oh gosh. Okay, this lab. All right, I think there's a range. Is there? 3 ranges. That's so crazy how we got between 3 sets of ranges. I think that's how you do it. Okay. 3 sets of ranges. Okay. 3 sets of ranges. If the halves are touching around Can y'all hear? Do you hear the music? Does everyone hear the music? Low 5 girl in the background. I'm not sure if you guys like that, but it's the only one that isn't gonna copyright strike me. I need some water. All right. Cool. Is it too loud? Too low? Oh, I guess if you can hear it, then it's probably not too low then. Around 25 to 35 blows. 35 blows. Oh, that sounds disgusting. I don't like coffee, man. I just stay awake. In fact, I just had all of my lights on. It's just right. Yeah, I bet it is. Collected data? Oh no, collect data. Collect data if the halves are touching around 25. I think that's the max, right? Okay. Around 25 and 30. That will be one trial. Oh no, that would be your, yeah, it's just trial, I think. That would be one trial. for the second trial. If the halves are touching, havers are touching around, I think it's 15 to 20 blows, right? 15 to 20. Collect a moisture sample from the soil in the cup. Close the cup. We can't determine the mass of the cup. Cup is various. Transfer the soil. Do 20 blows. That will be another. That's a big range. Wait, what? Would be 20 and 25? Let's say 20, 25. I forgot what it was. Darn tootin'. 25, I think 25, 35, and just 15, 20. Okay, wait, that makes sense. 25 blows, that's one try. If the halves are touching around 15 and 25 blows. Yeah, that's what I was thinking. Cause I forgot. And this thing ain't telling me. I wish I wrote down what the ranges were. Cause one range, cause we're doing 15, cause one of them is a minimum of 15. The minimum is 15, the maximum is 35, and the middle is 23 for our data sets. So, God, am I too stupid? I think I'm just too stupid to understand this. Well, I can't think right now. Google's not my friend. Google hates me. Oh, you know what? That's a good point. I'm gonna use Google. Where did Google at? Not here. Liquid limit tests. All right. Let's see what they say. I'm looking for the procedure, brother. Come on. Procedure. Yeah, there we go. Oh, I don't want to play a YouTube video because that might be... Oh, I was wrong. Okay. So 15, 20. Let's do that. 15, 20. Then 25 to 30. That makes more sense, I think. And 30, between 35. That will be another trial. And between 30 to 35 blows. I think that's right. A liquid limit test procedure. That's what I'm looking for. I couldn't see your comment earlier, so I don't know what you're looking up. I think I got it. I think I got it though. Okay, the cup will neither have the cup. What? Make sure neither half of the soil is touching. Crank the handle on the liquid limit device. The cup will move up and down. Alright, I can edit this tomorrow morning. That'll be fine. This will be counted as blows in for however many blows. Stop the crank when the two halves are touching. After that blows between 3 sets of ranges. Collect data if the halves are touching around 25 to 30 blows. That will be one trial. If the halves are touching around 15 to 20 blows, that will be another trial. The other trial should range between 30. The other trial should range between 30 to 35 blows. Put all soil samples into the cans. Put all the soil samples, put all the wet soil samples into, how about transfer? That's a better word. Makes me sound fancy. No, I don't want to save this file. Gosh darn it. No, I don't want to do that. I want to save on my computer. Save as environmental science. Liquid limit test. That's a good idea to save since I'm streaming. Transfer. I wish I had water. Transfer. I want to put more water in my Brita. Okay. Where are we? Why is my desk or chair so low? It gets lower. Okay. The other trial should range between 30 to 35 blows. Transfer all wet soil samples into cans to measure the total mass of the cans plus the wet soil. Did I say measure the? Yeah, I said measure the cans. Transfer all wet soil samples into the cans to measure the total mass of the cans. The wet soil. Then place the cans into an oven. At 110 degrees Celsius. I don't know how to spell Celsius. Celsius. There you go. That's not how you spell Celsius, but it's fine because Word fix it for me. Imagine if I was 2,000 years ago, or we didn't have Word. That'd be very awkward. Then place the cans into an oven at 110 degrees Celsius. For this lab, the cans were placed for 20. Place in the oven for 24 hours. I think 24 hours. Over 24 hours. Place in the oven. Wait. Right? 36 hours, right? Oh, I'm so lost. 1 day is 24 hours. So technically. Celsius was definitely a thing 2,000 years ago, except people didn't call it Celsius. They call it something else, like temperature. Obviously. For this lab, the cans were placed in the oven over 48 hours. Actually, yeah, if I think about it. 2 days? Oven for 2 days, not over 2 days. Then place the cans into an oven at 110 degrees Celsius. For this lab, the cans were placed into the oven for 2 days. Then, exit. Roman Empire units of heat. Yeah, exactly. That's the point. Always use the empirical method, as I always say. Then place the cans into that didn't make any sense at all. Use the empirical method? What? Then place the cans into oven. I'm having brain fart right now. 110 degrees Celsius for this lab. The cans were placed in the oven for 2 days. Okay. Bring out the cans. Bring the cans. Bring out the, I think I'm overthinking it. Bring out the cans. I should probably say you need to include the lid for these cans as well. Bring out the cans. Bring out the cans. Bring the cans. I think I'm overthinking it. Bring the cans out of the oven and measure. Let the cans cool off and bring, and then measure the mass of the cans plus dry soil. Okay. I think that's good for the next part. Okay. So after, let's see, I got to that part. Add more water to the paste. Oh, it says it right here. I'm so stupid. Good lord. Put 3 cans in moisture dry to constant mass. Alright. A series of calculations needed. I can't spell calculation apparently. Are needed. The first calculation is to find the moisture content loss. can't think right now. Okay, the series of calculations are needed. The first calculation to find the moisture content loss. Alright, moisture content loss. Okay, that one's easy. Then, plot a semi-log graph for moisture content, arithmetic scale versus number of blows in scale. Moisture content versus number of blows. This will approximate state length, which is called the flow curve from the straight line. Determine moisture content corresponding to 25 blows. This is the liquid limit of the soil. The magnitude of the slope of the flow line is called the flow index. What the hell does that even mean, bro? Don't know any of this. Everything's so vague. Moisture content. Okay, so moisture content. I only have 3 points, so it's not much of a good data set in my opinion. Test with n value between 20 will be reported. Use those values to estimate the comparative values of liquid using EQ 6.3. Okay, moisture content. The first calculation is to find the moisture content lost. Then create a semi-log. Semi-log graph representing moisture content versus, I can't spell versus as well apparently, versus number of blows. Nice. Okay. Based on liquid limit tests of several soils used by engineers, observe the liquid limit soil can be approximately given by the Is that it? I think that's it. I think the liquid limit was like flow index. Okay. It's not hard. It's not hard. It's just frustrating to read this much. Lastly, the liquid limit need to be found. The liquid limit needs let's calculate. Okay, and then compare data. Oh, I don't even need to do the math actually. I guess I don't need to, right? Six one. Oh, these are already finished ones. Oh man, imagine we did like 6 trials. I do be studying the earth science. Yeah. Smoker lungs. Let's calculate it. The liquid will be compared to the liquid limit can be compared Now to the fun part where I can data and results. Now to the fun part of Excel, which isn't so bad if I think about it. Should probably rename this liquid limitable. Okay. Item can number, mass of can plus wet soil, mass of can plus dry soil, moisture content, number of blows. Okay, test number. ES4, ES5, ES6. Yeah, buddy. Let's make my camera a little smaller. Let's zoom in actually on. Can I not zoom in? Here we go. Let's zoom in on the. Whoa, what just happened? There we go. So now my graph can be huge. And people can see my huge graph. Alright, mass of can. Oh, I didn't put the mass of can. That's awkward. Mass of can. There we go. Mass of can is 20.70. And then 20. Why is there police sirens? Good lord. I feel like there's police sirens every night. 20.69. Mass of can plus wet soil. That's my M2. 52.58. 41.42. I bet you do like a good graph. 42.41. Then 40.70. 33.80. Yeah. And 34.06 moisture content. Okay. Okay, my numbers say 60.9. I should probably do that by. Okay. So M2, which is my this subtract this divided by my M3, which is what? Mass of tries minus M1, and then times that by 100. Oh man, I am way off. Okay. They look and assume this one's a little odd though. Let's do 2 decimal places. Number of blows, 35, 23, 15. This one doesn't need decimal places. Okay. Now you just need to find the liquid limit. For the, not the liquid limit, but moisture content. was N1. You know, I thought I knew it, but I guess I didn't. Okay. Plot a semi-log. This will approximate a straight line, which is called the flow curve. Line determine the moisture content. So that's 59%. Oh my gosh, moisture content was close to 50%. Good lord. Oh yeah, that makes sense actually. But how am I getting it? Huh. I mean, the numbers are close. Yeah, the last one's very close. Flow index. Variation of table 60. Are these examples? Complete examples of liquid combination corresponding graphs are shown to log into N1. Well, which one's into N1 then? Oh, yeah. Okay. Log 30, 37, 33 points. Liquid limit. Am I going insane? I'm trying to figure out what to do. Liquid limit is 35.2. How did you figure that out, though? That's the question. Ay. Okay. I am lost of words right now. Okay, probably should read. This will approximate from the straight line, determine the moisture content. W percent corresponds to 25. This is the liquid limit, so the line. That's what I'm not getting. How do I calculate flow index? Alright, I guess I'm to Google something. Flow index. Can't believe this is the hard part. Flow index calculation. Flow index. Okay, liquid limit. Cascade method, best friend curve. W1 minus W2. Huh? Oh yeah, I guess. I need an example of what W1 and W2 are though. I guess this YouTube video is gonna tell me. Okay, I'm just very stupid then. Oh wow, I am so stupid. Water content 1. Okay. I am so stupid. Yeah. There. Okay. Okay. So this will be. Let's flow index. Flow index, which will be. Where did I get the what? Okay, maybe I should watch the full video first. There's always some Indian guy that tells me how to do stuff.
Casegrane method or cone penetration method. The flow index can water content versus strength.
Flow index. I just want the calculation, dog. Oh. Is this it right here? Oh. Massive weight of the container bowl with cell sample. So, massive container weight. Do I need to find a flow index for each one then? This is just so confusing. Wait, so this is 2930. Okay. Good lord, I am lost. Alright, how about I just make the freaking graph of moisture content with I spelled moisture content wrong? Yeah, I sure did. Copy. Just paste the numbers. Then paste. Oopsie daisy. Oh, wrong one. They should all correlate. It's weird how it's gonna be like this though. It's only 3 points on a graph. Well, that's not right at all, is it? Let's see. Logarithmic. Sure. This is not right at all. There's a fine line between right and wrong. I guess it's better to do on paper if I'm being honest. Yeah, I think I'll better just do it on paper because it'll be so much easier on paper. This graph sucks, not gonna lie. Oh, wait. What the hell? Oh, I have it backwards. I'm stupid. No wonder. Delete that. Be so stupid. Well, that's even worse. What the hell? Okay. Well, shit fire. Okay, whatever. Let's just figure out what the flow index is. So I'll take the average, whatever, and the average below, I guess. And this moisture content percent for. Hey, why are lab books so mean? Just learned my program was cut. Hey, bro, everyone's program's been cut. That fucking sucks. And I'm over here trying to do my best to study, to write this damn paper. Oh, I can't think. This graph sucks. I think it would be better if I had more data, but alright, flow index. Alright, flow index. Which is, I think it's, I'm gonna wing it and say this. It's this. So it's, what's W1? Flow index calculation. It's weird how I'm not getting what I want. Because this is, well, this is 23 or 58, 59. Maybe I switched them. Would that work? Would I switch them? Well, these are in order though. Alright, how about we go from bigger number, the bigger x to smaller x. Will that change anything? I don't think so. I don't know how Excel works. No. Okay. What am I doing? Oh, what the fuck? That's what I was doing. Okay. I'm stupid. I don't know. You can. I think you can continue until spring 2023, which isn't long, but. Alright, let's figure out this flow index right here. I don't know, you're a GTA, Grand Theft Auto. No, but seriously. Yeah, like I'm good. Like the physical science department got cut, and like I'm good I'm good until spring 2023, which is my last year, so it's fine. Yeah, I don't know who that other guy is. Is it Sam? I don't know who the other guy is, if I'm being honest. Yep, no idea who the other guy is. Guess it's a mystery for me. Alright, let's figure out this flow index. I think, what is W1? I had to figure out what W1 is, and then I can do the damn equation. W1's moisture content. Okay. So is the first moisture content, which is this one, minus the second one. Alright. Then divided by log 10, which is, I believe, Kevin. What do you mean? Who else will watch my streams? Technically, I watch my own streams. If we want to go there. Alright, so let's see. Number of blows. Blows 2. So. Okay. Well, what's isn't that subtraction, right? That should be subtraction. Cause when I'm minusing 2 logs or subtracting 2 logs, that's just log division by 10 or divided by itself, right? I think. Let's hope so. -4, that's not right at all. That's not right at all, guys. That is 100% not right. Yeah, that's not right, dog. We use an apparatus to give blows to solely plot a graph between these. Don't tell me I have to manually put it on a graph, because that will be really annoying. Because known as a flow curve, the slope of this curve can give us indication about the shear strength of the slope. Now using the right angle triangle, we determine that the tan theta. Why can't people ever just explain? Like, explain how to do stuff. I'm in love with the bar. Alright, this guy might have something.
Don't forget about spelling and grammar mistakes. Just click on the highlighted area.
हेलो फ्रेंड्स, वेलकम बैक। इस वीडियो को अपने दोस्तों के साथ शेयर करना बिल्कुल मत भूलिए। तो इस वीडियो में हम लोग पढ़ेंगे डिटरमिनेशन ऑफ लिक्विड लिमिट। आपको 3-4 अ पार्ट ऑफ सॉइल टूल होता है, कैसे
a good drawer, I'm not gonna lie.
टूल, तो इससे हम लोग बीच में खांचा बनाते हैं, काटते हैं।
I don't understand what he's saying, but it's fine.
क्या आ जाएगी? इसकी एक स्टैंडर्ड डायमेंशन होती है, flows together by a distinct संख्या है, यानी tool can be used for cutting the। हम लोग क्या करते हैं इसमें कुछ ना कुछ।
Let's see, I'm just watching a guy in India teach me how to।
W बराबर 20 माइनस log n। यहाँ पे जो बेस है वो 10 है। यहाँ पे दे देगा नंबर ऑफ ब्लोज 30, तो n की जगह हम लोग रखेंगे 30 और उसके करस्पॉन्डिंग हम लोग वाटर कंटेंट निकालेंगे। log।
Alright, how about we try? Let's try. I mean, it will be the same, right? Yeah, that's my percent, moisture content percentage. So, dude, this one, and then you have to divide it by log. Fucking me, dude. Oh my lord. Okay. This one, the parentheses, minus this one, divided by log. Let's just do log base of 10, because it's asking me to do too much. Into, so it'll be this one. Minus log. Probably get the same answer. That's even worse. Oh, I mean, it's matching up. Negative 9.5. I mean, it's literally matching, but it's a negative number, which is the problem. Yeah, I should be in one range, I think. Unless I ignore the numbers. Oh, wait. What? What the heck? I don't understand. They just put... Where do they get these random ass numbers from? Oh my gosh. Okay. I'm going crazy. I'm going crazy. Alright. The liquid limit. Is that just the average? Let me look on my phone. Tobuscus? No, that's not the average at all. 25. I think I take the average. And is that what he did? He took the average. Alright, I'm gonna do the sample calculation, cause maybe that might help. So let's sample. Where are the moisture contents? So 32.7, 36 point 36.04, 38.1. Okay, now the average for these. Oops. 35 point. Right. So that's the average percentage. Use this times. Oh wait, I didn't. I should probably. All right, blows. Here's blows. You blow. Blows. Blow. How about you blow me? Huh? Blow me. 35, 23, 17. I'm just doing the sample calculation. But, you know, you have to do the sample calculation. It's 25. Oh, okay. So it's... Wait, what? So it's this number times 25 divided by 25, which I assume is 1, to the power of 0.121, which is 35.6. How are they getting 35.2? That's what I'm wondering. That is what I'm wondering. But I don't know how they got 35.2. Okay, refers to method described section 3. As a multi-put method based on limit tests. So is U.S. company engineers. Where WN is the moisture content in percent for a 1/2 inch groove closer to liquid net device. That number blows. Presence. Okay, refers to a single pull method. However, the value should correspond to n value between 20 and 30. Table 62 T list the values of n. Oh, okay, so 23. Huh. Is that? Okay, so they have 0.990. Oh, that's even worse. I honestly don't know how they got that. Okay, so maybe it's not like average. I'm not set up for average. It also recommends the equation for determining the liquid limit of soils and refers to as a single point. However, the value of Wn should correspond to n value of between 20 and 30. Table 622 lists the values. Oh wait, is it 23? That's the only one that's between 20 and 30. That's how you do it. Okay. I'm stupid. So we only have one value that is listed between 20 and 23. Okay. So flow index, I don't know. LL, liquid limit. Alright. We're halfway there. So this one will equal, what was it? Percent. So average percent. Oh, I should probably do the average of this actually. So average, which is average moisture. Nope. Average moisture. And this will equal, I can't spell. No, don't do that. Alright, 615. That's not bad. Alright, 615 liquid limit is this bad boy times 23 divided by 25 with a to the power of 0.121. 59.9. That looks about right. That should. Yeah, 59.55. Goodness me. Alright, so we have that. We have the liquid limit, which is that. Now we gotta figure out the flow index. And I don't feel like doing the graph here because this graph is weird. And I don't like weird graphs. So let's figure out the flow index. Flow index. I have to read it. Okay. Plot a semi-log graph for moisture content at Riften scale versus number of blows in scale. This will approximate a straight line, which is called the flow curve. Straight line determine the moisture content corresponding to 25 blows. We don't have 25 blows. This is the liquid. Oh, that's the liquid limit. The magnitude of the slope of the flow line is called the flow index. Okay, complete examples of. Yeah, that's the problem. I don't know. I'm losing my mind. We've been streaming for 100 minutes now. That's crazy. Alright. Maybe someone else did a lab. Here. LL equals tangent B log NA minus log 25. Huh? Can I just get the flow index, man? I just want the flow index, man. Hey, let's see. Alright, flow index. Flow index. Okay. Liquid limit minus average minus log n minus log 25. Okay, this one might be useful. So average moisture content minus actually no. Alright, wait, what? This one is, so this one says it's the liquid limit minus the average flow content. Let me put parentheses here. Good lord, fuck off. No. What? No, 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 no. Okay. I'm trying to put parentheses, man. Divided by log base of 10, which is I'll say 23, I guess, minus log base 10, 25. Okay, well, shit. Why are they coming out negative though? See, the number is good, but it's negative. That's the problem. Like the flow index. No, it's not even supposed to be negative actually. How do you calculate liquid flow index? I already looked at that one. How to calculate flow index. Alright, maybe this guy has something for us.
Caring for your farm can be demanding, but the days are even
Bow chicka bow wow. Ooh, my shoulder hurts.
When we mix fine-grained soil in large quantity, now a sample soil stock liquid limit by use an apparatus water content. Numbers of blows are plotted on log scale. A best fitting curve is drawn through the experimental points.
Okay.
And we observe the graph is approximately a straight line.
Oh yeah, okay.
This curve is known as flow curve of soil.
Okay.
The slope of this curve gives us an indication about the shear strength of the soil, and it is known as the flow index of the soil. It is denoted as IF. Slope of this curve can be calculated by taking any two water contents W1 and W2 and their corresponding number of blows N1 and N2. Now using this right angle triangle, we can determine the tan theta, and that will be the slope of this curve.
Tangent.
Which is the flow index of the soil. Slope will be equal to this. And by log rules, we can write it as this. Be it the...
Alright, let me just put the sample calculation they have on this dumbass. I don't need any of this. Alright, how do I delete everything? Delete. Oh yeah, there we go. I don't need any of that. Sample. So the equation they have, or the sample calculation they have. Yeah, no fucking shit, dude. Indian people. I don't know. I'm always looking up to Indian people. I'm always grateful for them. They're working harder than me. Okay, 37 minus. But the moisture content. The moisture content. 37 minus 33.7. Alright. Divided by log base 10. Log base 10. Oh my lord. Lodi. Log base 10. I'm just gonna click on it, and then it will be, wouldn't it be 30? Right, it's 30. He said it was like 30. Well, I should hopefully get the same thing, right?
we can write it as this.
Log base, okay. Divided by 20. That's 18. Okay. So that's the answer I got from him. That's the same answer that matches exactly the sample calculator. So something tells me I am doing it right. But let's just, so W1, which is my oh yeah. This doesn't make any sense how it's coming out negative though. It doesn't make any sense at all. Okay. So W1, which is my moisture content. So let's pick this one because I don't know. This one minus this one, and then with their corresponding number. So divide by log base 10. Let's see, and then into do I actually physically need to make the graph? Ah, hold up. Maybe I have to make the actual graph. Alright. You know what? Fuck it. We'll make the actual graph. Gentlemen, today we are making graphs. Alright, thank God I have a fixed one. Okay. So this, the X values are going by 10, 15, 20, 25, 30. Okay. Let's have this more spread out. So it's not that linear, that's the problem. So I guess tens will be fine, I guess. So 10, 20, 30, 40, 50, 60. Wait, 10, 20, 30, 40, 50, 60. That's too much of a small graph. We can do 5, 10, 15, 20, 25, 30, 35, 40, 45, 60, 50. Oh, what? No. Can't count now. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I don't want to use the entire thing. I guess I'm 10, 20, 30, 40, 50, 60. I'll do 5s then. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 65. Which in the maximum is like 60. Okay. Cracker back. 5, 10, 15, 20, 25, 40, 30, 35, 45, 45, 50, 55, 60. And the highest was at 62. Okay, so the first number, first x to plot is our lowest value, which is 10, 15. 15, let's see. 15 is 62. So, this is like, okay. Any guy does not help at all. I just realized that. No, he might. I don't know. Good lord. Good lord, lord, lord. Alright, the next number is 23. Let's see. It's 35. Number of drops, moisture content percentage. This graph is so, it's not linear. I don't know how anyone's getting a linear graph. Log 30. Yeah, I can always watch more Indian YouTube videos. I don't get it.
If you see your state, you can register to vote online right now. It only takes...
I'm gonna watch the same video.
Be it the Casagrande method, number of blue versus a soil with higher value of flow index is said to possess a lower shear strength than that of a soil with a lower value of flow index. We can see that by considering flow curves of these two different soils. At water content W1 and 1. Now if we slightly two of water in the Casagrande curve.
I have no idea.
Slope curve is drawn through the experimental curves.
Alright.
Casagrande method and cone penetration method. In Casagrande method, we use an apparatus to give blows to the soil.
That's the method I
of
did.
Different water contents. We plot a graph between these experimentally obtained numbers of blows and their corresponding water content. Numbers of blows are plotted on log scale. A best fitting curve is drawn through the experimental points, and we observe the graph is approximately a straight line. This curve is known as flow curve of soil. The slope of this curve gives us an indication about the shear strength of the soil, and it is known as the flow index of the soil. It is denoted as IF. Slope of this curve can be calculated by taking any two water contents W1 and W2 and their corresponding number of blows N1 and N2. Now
I guess it doesn't matter which points I pick, right? But the problem with that is it's not a linear graph. Oh my lordy. Okay. I don't know if this one's even right. I think I did something wrong. Okay, so the mass of the cans are 20.7, 20.85, 20.69. Mass of the can wet soil is 52.8. Oh. Oh dear. Ha! Look at that. Does that make more sense? I think that makes more sense. 20.85. Okay, 20.85, 41.42, and 33.82. That makes a lot more sense, because now it's more linear. Okay. I was like, what the heck, dude? Okay, delete that. Oops. Can't believe I had the wrong number the entire time. Good night. What's happening? It's like a oh, that's all over the place now, great. If I can't figure this out. I'll make sure I save this just in case. Okay. Well, it's 11:30, so I think it's a good idea for me to cut my losses here. Alright. Good night, everyone. Bye.